When we do distribution, this is what we mean. When we have a number outside of brackets, as you can see here, so we have A outside of the brackets, which include B plus C. What happens is when we apply our distributive property, what actually happens is we say we go and we multiply this number on the outside into every single term inside my brackets. Okay. Now, what does that end up as? It ends up as A times B, which gives us AB, plus A times C, which gives us AC. So I know you guys know this rule, and most of you will be familiar with this rule. But I think this lesson is really, really, really just going to drill this principle into you. Because a lot of times I see us getting questions, getting these expressions where there's brackets, and students are like, but ma'am, I'm lost. Ma'am, what do I do? Ma'am, I don't know. So this is what we do. The minute you see these brackets in an expression and there is a number outside the brackets, you are going to use the distributive property, and that means multiply into your brackets. And so really what it says is when we have a sum, and this is my sum, B plus C is my sum. When we have a sum that's being multiplied by something, the answer to that is the same thing as taking this coefficient over here of A and multiplying it to each term inside the bracket, to each part of my sum. So that's just a technical way to phrase it, the distributive property. But if you can understand what's happening in this picture, then that's all you need to know. When we have brackets and there's something outside the brackets, what we do is we distribute the number outside my brackets into the brackets. And already you guys know, if we have something like 3 and then 2, already you know what we do here is it's multiplication. The operation here is multiplication. And so 3 times 2 is going to give me 6. Now what we're saying is when you have something like 3 and 2 plus 7, what actually happens is we still say 3 times 2, but we also have to say plus 3 times 7. And so that is going to equals to 3 times 2 plus 3 times 7, which would be equal here to 6 plus 21, which is equals to 27. Okay. Geometry, guys, we're starting geometry next term. So I know a lot of you have started it in school, but do not fear. We will cover it soon in the coming term. And if you really, really, really need help, go and watch the videos from last year on geometry on the Watobi YouTube channel. Okay, so this is our distributive property. Can you all, or let me do another example before I ask if everyone is okay with it. Let's say we have something like 7x squared plus y cubed. Okay. Now, what I want you guys to remember is when we are doing multiplication and division, what rules apply? My exponent rules apply. When we are doing addition and subtraction, what rules apply there? Well, then my like term rules apply there. Now remember, when you are adding and subtracting like terms, what happens is my exponents and my variables do not change. But when you are doing multiplication and division, that is when you apply your exponent rules, and that is when your exponents will change. So, will there be class when school closes? Usually, yes, we do still have classes during the school holidays, but for June, we are closed during the 2 weeks of June. So I think it's from the 15th to the 30th of June is when we are closed. And I think you guys are on holiday then, but we are starting 1 week before you actually go back to school. So this middle year break is the only break that we'll take from MathsLive classes. Other than that, we will have classes throughout the school year, whether it's school or holidays. Okay, so if we have something like this, remember now what we're doing is we're distributing in, and when we distribute, we multiply. And because I know that I'm doing multiplication, I can apply my exponent rules. And so I actually want to change this to something like 7x. Okay, what that means is now I have 7x times x squared plus, and I keep my plus from the middle here because it's a positive times a positive, which is going to give me a positive, and 7x times y cubed. And what happens is now when I do this multiplication, I'm going to apply my exponent rules. And so over here, 7x times x squared. Well, if I apply S in V, let me multiply my signs here. It's a positive 7 times positive x squared. So I'm going to get a positive. Let's multiply my numbers. Well, the only number there is 7. And then if I multiply my variables, it's x times x squared. And when I multiply my variables, my exponent rules apply. And that tells me when I multiply exponents that have the same base, I can add the exponents. And so that is what I've done over there, because remember 7x also has my invisible exponent of 1. And then I go ahead and I say 7xy cubed, because that is how I multiply. I can just get rid of my brackets. I can get rid of my brackets and just write it next to each other because I know that means multiplication. I can't add exponents here because it's not the same base. And remember, what do I mean when I talk about a base? I'm talking about the actual variable itself. X and Y, those are not the same bases. So I can't add my exponents. I could add my exponents. Uh-oh, give me a second. I could add my exponents when I had x and x because those were the same bases. So just something important for you guys to remember. And then the final answer would be 7x cubed plus 7xy cubed. And now that I have this, now I see, okay, I have addition. What I can do is I can look for like terms. Can you guys tell me, do I have like terms over here? In this step of my expression, do I have like terms? Rory-san is saying no, and you are correct. Um, they are unlike terms. Why? It's not the same variable and it's not the same exponents. So they're not like terms, and this is as far as I can go. So in this distributive property rule, can you guys give me a happy face or a sad face to let me know if you understand what just happened here? Nkuli is very sad. That's a very sad face. Nkuli, what's the problem? I did see your question, and I wanted to get back to that once I was done explaining. The question that you've asked is a very long question, and it's a very complicated question. And by the time we've done order of work, remember we still have to do lesson 4, 5, and 6 in my algebraic expressions. So once I've done these last 3 lessons, we will 100% be able to answer the question you've put in the chat. But for now, as far as we've gotten, I don't want to answer your question and confuse everybody if we haven't gone through the actual lessons that cover the work that's going to relate to that question. Alia has a question. Ma'am, when do we do finance, like simple interest? You can see here after our algebraic expressions, course 8 is financial math. So that is when we will do simple interest. So it's 2 weeks from now, I think. Shady is in between. Liahu, I see your hand raised. I'm just looking. Itandile is also confused. Okay, if you guys are confused, feel free to raise your hand and ask questions. Yes, Liaho.
Sorry, ma'am. I'm late, ma'am, because I think I went out, ma'am. Sorry, I'm late.
That's
Plus,
okay.
plus I'm a little bit sick.
Oh, I'm so sorry to hear that. But it's okay. You didn't miss much. All that we've gone through is we've gone through this distributive property where when we have something outside our brackets, we have to multiply it into our brackets.
Okay,
And
ma'am.
I've
Thanks.
given some examples. Cool. Pleasure, Liaho. Yes, Itandile.
Ma'am, can I please ask, where did you get 7x to the power of 1 bracketed x to the power of 2?
So are you asking me about this step over
7,
here?
yes, ma'am.
Okay. So remember, we are multiplying. And so I didn't actually do the multiplication. It's like I did here. I said 3 times 2 is 3 in brackets 2. So here, 7x, and I follow my line, times x squared is 7x in brackets x squared. You seeing that?
Yes, ma'am.
Okay. Does that make sense? Are you better now?
Yes, ma'am.
Okay, great. Okay, Bila is asking to explain again. Okay, so I'm going to explain this one more time before we move on to examples, because I do think it'll start to make more sense once we have examples in. And so actually I'm going to move on to the examples, but when I do the examples, I will still be re-explaining the concept over and over again. So for now, I'm just going to scroll down. Okay. And so we see here, we have example 1, simplify the following. So let's only focus on this bracket first. We're going to ignore the second bracket while I explain what's going to happen in this first bracket. So I'm just going to give myself some space to work over here. So that's that. And then what happens is with my distributive property, what I said is when I see that I have brackets and then I have a number outside the brackets, what I have to do is I have to go and take my number outside the brackets and multiply it to the terms inside my brackets. So on that note, can you guys tell me inside my first bracket, how many terms are there inside the bracket? Shady is saying 1. Uma says 2. Refilwe says 1. Now remember, guys, when I say inside the bracket itself, yes, is 1 term. But if we look at what's inside the bracket, there's 2 terms, okay? There are 2 terms inside my brackets, which is 2x and -1. When I look at the bracket itself, the bracket is 1 term. But if I look inside the bracket has 2 terms, okay? So what we're then going to do is I take my number outside the brackets and I multiply it to the first term in the brackets. And then I take the number outside the brackets, which is 4, and I multiply it to the second term in the brackets. Okay. So I see the message in the chat, guys. Please let's keep this chat classroom appropriate. That's sad. And so yes, what we've gotten there immediately, so it's 2. So what is 2? 2 terms inside the bracket, yes. Now when we do our actual multiplication, what will happen is 4 times 2x is 8x, and 4 times -1 is -4. Okay, so that's just with my first bracket, sorry. That is just how we apply this distribution principle in my first bracket. But now there's also a second bracket that I have to deal with. And so in dealing with my second bracket, I firstly have to go in and multiply in. And you might be saying, but ma'am, there's no number outside my bracket. Well, there is. It's this invisible 1. Okay? It is an invisible 1. And so when I do that, it's going to be -1 multiplied by x, and then -1 multiplied by -1. And then when we add all of it up together, we're going to get 8x minus 4. And let's do the multiplication here. -1 times x is going to give me -x. And negative times the negative here is going to give me a +1. Now, do I have like terms over here? Can you guys tell me, do I have like terms? Itandile says no. Umar says yes. Alia says yes. Okay. So this is the steps I want you guys to follow. The first thing we're going to do is we're going to do our distribution. What do I mean when I say distribute? It's exactly what we've been learning here. When there's this number outside brackets, we take it and we multiply it into every term inside the brackets. Once I've gotten the answers to all of that multiplication, I can add like terms. And the way I like to remember adding like terms, I told you guys about the fruit bowl, but also I draw shapes around it. So that's a circle and that's a circle, and that's a square and that's a square. So if I have eight circles, I have 8 circles over here, and then I minus 1 circle. How many circles do I have left? I have 7, but 7 what? 7 circles, okay? And so what I want you guys to remember is that when we're doing like terms, our exponents, and variables don't change. Okay, and so that's that. And then when we look at these squares over here, -4, so I have -4 squares, I plus 1 square, that's going to leave me with -3 squares. Okay. Ma'am, the full answer is 7x minus 3. That is 100% correct. Valentine is confused. Valentine, where did I lose you? Was he talking about circles and squares? Yes, Valentine.
Ma'am,
Mm-hmm.
how are you, ma'am?
I'm good, thank
Ma'am,
you.
you lost me by the -1s and the zeros, ma'am.
Zeros.
Yes, ma'am. The
Okay.
circles and by -1.
Okay, so are you happy that I've drawn this purple circle around 8x and -x because they are like terms?
Yes, ma'am.
And I've drawn the squares around -4 and +1 because those are like terms.
Yes, ma'am.
Okay, what I then did is I was just explaining how to sort of understand adding like terms. The way I like to think of it is we have 8 circles, okay? So if you look, I've drawn circles around 8x. So I'm saying those are circles. I have 8 circles, and then my other circle is -1 circle. Okay. And so tell me, Valentine, what is 8 minus 1?
7.
It's 7. But was I actually in the sum? Was I actually dealing with circles? No, I was dealing with x. And that is how I got the 7x over there. Do you see that?
Yes, ma'am.
And so I know this looks like 80 and 10 right now, but it was just little circles. Okay, so I hope my circles and squares didn't confuse you. But if it's confusing you, then erase it from your mind. Erase it, and
Okay,
however
ma'am.
you know how to add and subtract like terms, then that's the way that you are going to use that works for you. Okay,
Okay, ma'am. Thank you, ma'am.
pleasure. Okay. I see some random stuff happening in the chat. I'm just gonna ignore that for a little bit. Because I do want to do another one. Okay, no. Before I move on, everybody, again, can you give me a thumbs up or a thumbs down on how you are feeling about distribution? Okay, Bree has given me a lot of thumbs ups. Alia is good. It's good immediately. Okay. So what I want you guys to see is last week you learned about like terms, and now this week we're learning about distribution. But as we learn new things, we're combining our knowledge. So now that we've distributed, we're then gonna go and add like terms. So Shady, you're still in between. If you can let me know specifically what's confusing you so that I can address it directly with you, that'll be great so that we can eliminate that confusion. But yes, okay. Moving on then, sorry, because I added space, all my numbering is going to be out of whack. So just ignore that it's all going to be number ones. Okay, if we look at this next one that we're doing, again, what I can see is that I have a number that is outside my brackets. So what I need to do is I need to go and distribute. So I have two questions for you. My first question to everybody is, how many terms are there in this entire expression? Liako says 2, Itandine says 3, 3, 3, 2, 3, 1. Kaylee is the first one to get it right. There is one term. Now, you might be like, no. Let me explain. Let me explain. Remember, okay, if you don't remember, what I had said in one of our previous lessons, it was last week, Tuesday actually, where when we were talking about terms, I said that terms are anything separated. It's separated by either a plus or a minus sign. Okay, but when there's brackets, then it keeps everything together as one term. So when there's brackets, and I remember someone saying in the chat that basically the signs inside the brackets are irrelevant. Yes. So when there's brackets, you are basically going to ignore the plus and minus signs inside the bracket. Just you are going to basically go and ignore the plus and minus signs inside the bracket. Okay, so if I asked you, Alia, you were the someone in the chat, yes. So it's irrelevant. When I'm asking you how many terms there are, this bracket sign is basically hugging these two terms and saying you want it to be two terms, but no, I'm holding you and I'm squishing you and I'm combining you and you're going to stay one term. So really, all of this, everything inside our bracket is one term. And then you might be saying, okay, but ma'am, if that's one term, then why isn't 4x another term? Well, is 4x separated from our bracket by a plus or minus? No. So because there's 4x, and then there's my bracket, and those two things are not separated at all by pluses or minuses. In the entire expression, there is one term. That was my first question. So I hope everybody's happy with that. My next question is then, in the bracket, how many terms are there inside my bracket? 2. Shady, I'm happy to see your answer. I'm hoping that that means confusion is slowly but surely being eliminated. Yes. So inside my bracket, there are 2 terms, but in the whole expression, there's only 1 term. Because remember, when we look at the entire expression, we ignore however many terms are inside the bracket. Okay, so that's that. Now that we know we have this 4x outside my brackets, yes, Itandile.
Ma'am, can I please ask?
Mm-hmm.
Ma'am, on the last one, ma'am, why did we put plus between 4 bracketed 2x, then close bracket plus 4 bracketed -1? Why did we put plus there, but then there was no plus? It was minus in the bracket and outside the bracket.
Okay, so for which one are you talking about?
The first line, the first numbers.
This. You're talking about
Ye-
this.
Yes,
Okay,
ma'am. Why did we put
so,
plus instead for minus?
okay. My format here is a little bit wrong because remember, I only worked with 1 bracket at a time. So the correct format here should have actually been this, and let me show you. The correct format would have been this, and then it would have been, sorry, and then it would have been this, and then this. This is the correct format. Remember, I only started dealing with 1 bracket at a time. So what happened here was I said 4. For my first bracket, it's 4 times 2x, and that's how I got this. And let me get up here now. 4 times 2x, and that is how I got this. Do you see that?
Yes, ma'am.
And then I said 4 times -1, but it's a positive 4 times a -1. Are you seeing that?
Also, the reason why we said positive plus is because the 4 outside the bracket is positive, not negative.
Yes. But you have to make sure to include your negative inside the bracket.
Yes, ma'am.
Okay. And then what I did in the next bracket was then -1 times x. Why was this one a minus? Because my number outside the bracket was a negative.
Yes,
And
ma'am.
then for the next one, negative and a negative again. You seeing that?
Yes, ma'am.
Okay. Hope that helped, Itandile. Yes, Rory-san.
Ma'am, I was doing. Can you please go down?
Mm-hmm.
I was doing that
Mm-hmm.
and then I'm not sure if I got it right, but I got 3 answers.
Okay. Do you want to take me through what you've done?
First I said 4x.
Mm-hmm.
And then I done the brackets and said
Mm-hmm.
x2.
Mm-hmm.
And then I closed the bracket. Then I said plus,
Mm-hmm.
and then I said 4. And then I was not sure about minus. I'm not sure if it was going to be a
So did you just say 4
-2
or
or
did you
just
say
a
4x over here,
minus.
Rory-san?
I said 4x and then done the
4x.
same.
Uh-huh.
Yeah.
And then open brackets, and you didn't know whether to put the minus in. So what did you do?
And so I left it and said 2y.
Okay. So then my question to you is, where did this poor minus sign go to if you just left it?
I done it afterwards.
Okay. Remember now, when we're doing our expressions, we want it to flow. So if there's a negative sign here, I have to include my negative sign here as well. Even if I leave it out in this step and include it afterwards, your answer might still be right, but your format is a little bit wrong. So you might not get all the marks for your steps. Are you seeing what I'm saying?
Yes, ma'am.
So because this here was 4x times negative 2y. And so we're going to write here 4x times negative 2y. You seeing that?
Yes, ma'am.
Okay, great. Now from here, tell me what you did.
Then, ma'am, I said equals down there, and I said,
Mm-hmm.
4. I get this an imaginary 1 there.
Mm-hmm.
So, and since it's multiplication and the same
Mm-hmm.
base,
Mm-hmm.
so I said 4 times 1 is 4, and
Mm-hmm.
then I put the imaginary 1 at x and said
Mm-hmm.
plus 2.
Mm-hmm. Good job.
Yeah, and then I said plus,
Mm-hmm.
and then I said 4x times negative 2,
Mm-hmm.
and then I got 8. It's gonna be 8xy.
Okay, is it 8?
Yeah, 8xy.
Remember now what happened is that this, we included a negative here. So now it's 4 times negative 2.
Yes, ma'am. Oh,
So
negative 8.
there you go. So it's not going to be a plus anymore. It's going to be minus 8xy. You happy there?
Yeah, I'm happy there.
And then I'm just going to erase this 1 plus 2 and I'm going to make it 3 now. And then from here, what else did you do?
Ma'am, like, is that the answer, or is it like, do I still carry on?
Well, can you carry on? You tell me.
Ma'am, oh no, I can't carry on.
You can't carry on. Why?
Ma'am, I get there's no what is this thing that tells me what to times
Yes,
or
I
multiply.
know. Yes, there's no like terms. Okay. So
Yes, ma'am.
there's no more multiplication and division, so I can't do exponent rules. There's only subtraction here, but they're not like terms, so I can't subtract them. And so that means we're done. Okay,
Yes, ma'am.
so that was it, Rory-san. You did a good job on that. Well done. I see
Thank
there's a lot of talk in the chat. I hope that everybody was paying attention. Can you guys please let me know, do you understand how Rory-san and I got to this answer? And somebody asked to go back for a screenshot. I'm just going up, so now's your time for a screenshot. Okay. What is that? I don't know where the time flew today. Time has actually flown. What I'm gonna do then is move into our brain break. We're gonna spend 4 minutes on this brain break. The first thing is would you rather? Well, not the first thing. We are doing would you rather. So yes, I do apologize for our 4-minute brain break, but it's better than a 0-minute brain break. So, first question, would you rather be chronically underdressed or overdressed? Personally, I'd be overdressed. Yes, Liaho.
Ma'am, definitely overdressed. Definitely, ma'am.
Yes, I'm glad you
Yeah,
agree
ma'am,
with me.
definitely.
Why do you say that?
Ma'am, I don't know, ma'am, because like, also me, ma'am, like usually, I don't know, I think I like being overdressed actually, naturally. Just think
Same.
about it. Yeah, just
Me too.
naturally. Yeah, that's true, yeah.
Okay, thanks, Liaho, for that. Yes, Rory-san.
Ma'am, like, ma'am, that's chronically, ma'am, like, do you mean like when you're disabled or something? I don't understand the
Yes.
question.
So chronic, usually when we talk about chronic, you'll hear the word used with chronic diseases, but chronically just means it's like unchangeable. You know, it's I actually don't know what a textbook definition is, but it's something that always, it's there constantly. So would you rather always be underdressed or always overdressed? So in this sense of the word, Rorisang, we're not using it to mention diseases. We're just talking about always. Would you always be overdressed or always underdressed?
My mouth keep it simple, so underdressed.
Okay. Okay. I mean I see how it's a bit hard to always be overdressed, but yeah, that's cool, everybody. Okay. Next one. Would you rather swim in a pool full of Nutella? Also, this might bring some debate, but I say Nutella. I don't have it in me to say Nutella. But would you rather swim in a pool of Nutella or a pool full of maple syrup? Yes, Itandile.
Ma'am, I have beef with your people. Ma'am,
Wow.
it's Nutella, not Nutella. It's Nutella. Nutella. Guys,
I'm
it
sorry.
is Nutella. I have beef with y'all. No way, it's Nutella. Nutella, not Nutella.
I hear you and I respect you, but I'm gonna continue saying Nutella.
It's Nutella, guys. But I would rather swim in a pool of Nutella, not maple syrup, because like maple syrup is a bit disgusting. No
Yeah,
way.
very, very sweet. I get that, Itandile. Thank you. Okay, let's hear from Brie, and then I'm moving on to the next one.
Hi, Meg.
Hi.
Personally, it's Nutella. I don't agree with Itandila's pronunciation. Respectfully, it's Nutella. I would choose
I
Nutella,
agree. Yes.
yeah, because like it's chocolate and maple syrup
I,
is just there to exist. Like it's chocolate. Who is like
yeah,
who is
I agree, Brie. Also, on the pronunciation, I don't know if I'm dreaming about it, but I remember specifically seeing like the person who invented it saying it's supposed to be Nutella. But for me, it's the fact that literally what Alia said, it's made of nuts. It's Nutella. Rorisang, you can keep your hand up, but I'm going on to the next one. Would you rather be royalty 1,000 years ago or an average person today? Rorisang, I hope you've had some time to think about it, but yes, royalty 1,000 years ago or average person today?
I'm like royalty, man. I want everybody to know me.
But like 1,000 years ago, there wasn't TV or internet, so nobody would know you really. Only the people that was like in your town, you know.
It's better than being an average person.
I guess. Okay, thanks for resigning.
Thank you.
Okay, and I see we have two hands up. Lilago, you've answered one. So you're gonna just put your hand down because our brain break is over. Nkuli, you're gonna answer this last one, and that's the last hand I'm taking. Would you rather always be 10 minutes late or always 20 minutes early?
Hi, ma'am.
Hi.
Ma'am, I would always be 10 minutes late.
Same. I hate being early.
Because you have to wait for people and
Mhm.
it doesn't make sense to me. So
And
I'm
now you're
like,
annoyed. Now
I'd
you were
rather
rushing to
be,
get done on time. No,
yeah,
I agree with you, Nkuli.
yeah. Thank you, ma'am.
Thank you for answering. Liako, I see your hand up and I feel so bad, but I'm not taking your hand because I really, really, really have to
That's
get
so
back.
harsh, ma'am.
I'm sorry. I'm sorry. Um, okay, back to maths, everybody. Also, please let us stop with the debates in the chat about pure maths. I do teach pure maths, not at MathsLive. I do my own lessons, but pure maths is irrelevant to what we're doing right now. So let's not talk about that because it's all over in the chat and I'm confused about what's going on there. Yeah, but thanks. At least you answered in the chat 10 minutes late. I agree with you. Okay, next one. Anybody want to answer this one with me? No? Okay, while someone works up the courage to answer with me, I have a question. How many terms are in the expression? One term in the expression. Thank you. How many terms are in the bracket? 3. Thank you. Very, very happy to see that. Now that we have that, yes, Itandile, are you asking me a question or answering with me?
I'm answering with you.
Yay, I'm super happy to hear that. Let's go. Okay, tell me what we're doing.
So now we're gonna say negative 2xy to the power of 2. Then we bracket negative 3x. Then close bracket. And then we're gonna say minus. And then we're gonna say negative 2xy to the power of 2. Bracketed negative 6y.
Good job.
Minus negative xy to the power of 2. And then we say bracketed negative positive 4x.
4x. Okay, Isandile, just stay there. I'm just going to explain to everybody what we have just done. So, if you're confused at what we did to get to this step, remember we have a number outside my brackets. And what I had to do is I had to go and distribute this number outside the bracket into my bracket. And so that's what my purple lines are there for. I said negative 2xy squared times negative 3x, and that's how I got this. I said negative 2xy squared times negative 6y, and that is how I got this. And then I said negative 2xy squared times positive 4x, and that is how I got this. Okay? So that's that. Yes, Itandile, next.
So, ma'am, we're gonna start with the first bracket. We're gonna say negative 2xy to the power of 2 times negative 3x, which is gonna be 6x to the power of 2, y to the power of 2.
Exactly. Now, just hold on for me, Itandile. How did I get that to everybody who is confused? Remember, when we do multiplication, whenever we do multiplication, I can apply SNV. Multiply our signs first. Over here, I had a negative times a negative, so it gave me a positive answer. Then I multiply my numbers, which is 2 times 3, so it gave me 6. Then I multiply my variables. It was x times x, which I can apply my exponent rules, add my exponents, that's how we got x squared, and multiply by y squared. But I know I don't have to write in that multiplication. I can just write it next to it. Let's simplify now my next term over here. Yes, Itandile.
Plus, how we got plus was when you say negative 2 times negative 6, which is positive 12. Then we say x, y, 2 plus 1, which is 3.
100%.
And then we're going to say negative 2xy cubed times positive x, which is going to be negative 8x cubed y cubed.
It's y squared. Remember that.
Yes,
Oh, no,
ma'am.
wait. Yeah, no, it's y squared. It is y squared. Okay, because remember here we had the square out there. Okay, now that we have this, Itandile, now what?
Ma'am, we're gonna basically, ma'am, we're gonna don't we leave it like this? Oh, we do our unlike terms, and yeah, we're gonna plus our unlike. We're gonna say 6x cubed y cubed minus x cubed.
Itandile,
which
it's
is
squared.
y squared, sorry,
Mm-hmm.
which is gonna be negative, 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 negative 2
Mm-hmm.
x y squared plus 12 xy
Cubed.
cubed.
Cubed. And that is it. Thank you, Itandile, for answering with me. You did beautifully.
No, ma'am, I didn't.
What do you mean?
No, ma'am, I did not. Did
Yes,
not.
thank you, Itandile. And then somebody asked me, how did I get 12xy cubed? How did I get that? Remember, I got that from over here. What we did when we apply SNV over here, multiply our signs, it's a negative times a negative, which gave me my positive. 2 times 6 is going to be 12. And then xy squared times y. Well, my x is going to stay the same, but my y, I can add my exponents because it's the same base. And so I said 1 plus 2 gave me 3. I don't know why this is not erasing, but I want it to erase, but that's fine. And I have a 3 over there. And that is how I got that answer. Okay. So that's that. I'm gonna leave that one, and I want us to do a difficult one before we go. Okay. Now, what I want you guys to see is when we have a question like this, that's a fraction. When we have a difficult one that is a fraction, the first thing that we're going to do is we are going to see, are there like terms that I can add? Like terms in either my numerator or my denominator, okay? So if I look just at my numerator, are there any like terms in my numerator? Can you guys let me know? Yes, there are like terms. Remember, like terms have to have the same variables and the same exponents. Rory-san, I don't know if you just picked up your hand, but if you did, yes, do you have a question for me?
Ma'am, like I'm confused. How are they like terms when none of them have the same like variable?
They're
Like
not
not
like terms.
all of them are.
Yes, they're not like
Yeah,
terms. You are very right.
and I feel
Everybody
like
was saying yes. I think everybody
the
just
answer,
saw the first yes and was just jumping on and saying yes, 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 yes. But you're right. They're not like terms. They don't have the same variables and exponents.
and I feel like the answer is gonna stay the same.
It would stay the same, except I can go and I can separate these fractions, Rory-san. So I can write this as 3ab squared over ab plus 2a squared b squared over ab. Do you understand how I've split these fractions?
Yes, ma'am.
Okay, it's the same thing like when we have 8 plus 3 over 7. We can split that into 8/7 plus 3/7. Okay, and now that I've done that, what I can do is I can say, well, this is going to be, and this is now, if I look at this first term, this is going to be a1 minus 1, which is going to be a to the power of 0, which is just going to be 1. Then I have b squared divided by b. That's going to be b2 minus 1. Then I have a squared. I have divided by a, so I'm going to minus 1 there. And then b squared and divided by b. And then I'm going to minus 1. Do you see, Rory-san, how I simplified all of that?
I see, ma'am. I see.
Okay. And so now, while you're here, can you give me what this answer is going to be?
It's gonna
What's it?
be 3
Mm-hmm.
3 B1.
Mm-hmm.
No, 3 B1
Yes, it is B1.
plus
Mm-hmm.
plus Ishmael, I can't see with this comment. Yeah, plus 2a to the power of 1,
Uh-huh.
and then b to the power of 1.
B to the power of 1. And that's it. Do we have like terms now, Rory-san?
No.
Nope. So am I done?
Yes.
Yes. And that is that. Thank you for helping me, even though you didn't volunteer to do it, Rory-san.
Thank you.
Pleasure. Okay, guys, and that is it for our lesson today.